molecule is that the
yeah,
given.
so chiral molecule it would be where there is not a plane of symmetry, right?
Absolutely, very good. There
Yeah.
is no
And
symmetry.
yeah, if there is, it's meso, right? Or that's within this structure or the molecule itself.
Yeah,
Meso, there's a plane of
yes,
symmetry.
meso.
Yeah.
So for a meso compound, what sort of conditions we needed in case?
Meso
Yeah,
compound, there needs to be a plane of symmetry and center of
center
symmetry,
of
right?
symmetry and plane of symmetry. Very good. And there is one more thing that they are mirror image of itself.
Yeah.
Great. Meso. Then there is one more term that is epimer. What is epimer?
Hmm. Apimers are like when you have along a carbon chain, then there's going to be a one group or one part of the chain that's different, right?
Absolutely.
Like the chirality switches in one carbon.
Yeah. Great. And what is anomer?
Anomer, anomer is like when you have a carbon ring where you have oxygen. So that's very specific to like if there's oxygen in the ring.
Yeah.
So that's this, but it's the same concept as an epimer. It's like one change. So both
Mm-hmm.
epimers and anomers are diastereomers.
What is anomeric carbon?
Anomeric carbon is like, yeah, if there's one change in a chiral center,
Mm-hmm. In case of
then yes, the
hmm.
anomers, it's like there's going to be oxygen in the ring.
Anomeric carbon is specifically the carbon which is adjacent to the oxygen. Okay, that is anomeric carbon.
Okay.
Okay. Then
Yeah.
enantiomer. What is enantiomer?
Enantiomers, there are two different molecules where they are mirror images of each other. So there's yeah, so they're symmetric, like there's a mirror image, or all of the chiral centers in that molecule have been changed.
Very good. All chiral changes. Okay. Then what
Mhm.
is diastereomer?
Diastereomer, it's going to be like it's different from enantiomer in that it's not all like not all the centers will change, but at least one or more.
Absolutely. And they are not mirror images.
Mhm.
Great. Okay. So these are the basic terms which we are using. Then the next part that is Fisher, 3D, Newman, okay, and so on. Okay. And what is R and S?
Um, R and S.
Yeah.
So like it's a principle, like it's a term for absolute configuration, which means that's how
Mhm.
we determine the placement of the different bonds and like, like what direction the molecule is moving. So based
Yeah.
on the bond. So clockwise it's going to be R and anti-clockwise it's going to be S.
Great.
And in terms of like if we're looking at
Okay.
the lowest priority must be like
Mhm.
if you're looking at a Fisher diagram, it must be on the top or bottom. If they're on the left or right, then they must be changed. The
Very
configuration must be changed of the molecule, yeah.
nice. Very good. Change. But if fourth group is on the top and bottom, then
Then it won't
it
change.
not changes. Okay. And let's suppose this is for Fisher. And if we
Hmm.
are talking about uh, 3D molecule. So in case of 3D molecule, if fourth group is on the dash side, then if
If
fourth
the
group, let's
fourth
suppose
group is,
fourth group is on the dash side. So in
yeah.
that,
Hmm. Yeah. So if it's on the
Yeah.
dash side, then it doesn't require you to change the configuration. However, if it's wedged, then you would need to change the configuration.
Yes, so fourth group, when fourth group is on the dash side, then no change. And if fourth group is on the wedge side, so it will
You
be
must
change.
change.
Great, great. Okay, then we discuss R and S. Let's suppose if we are discussing R and S on chair confirmation. Okay, so how we will discuss that?
RNS on chair conformation, it would have to be, it involves two types of bonds, axial and equatorial bonds on
Yeah.
each carbon.
Mm-hmm.
Axial goes straight up or straight down, and then equatorial is slanted to one side. Um, and they have specific placements at each carbon. Um, so equatorial bonds are more stable, so it's easier to move them around, whereas like axial is not, so you might have like some a diaxial interaction, like 1,3 diaxial.
Absolutely.
So
Very good.
yeah. So in terms of RNS, like you would have to consider like the two types of bonds, which is the main difference between like what you're looking at Fisher or the regular wedge dash diagram.
Great. So, like, how I identify that the given bond is on wedge or given is on the dash?
If it's on the wedge, that depends on the Fisher placement of it on the Fisher diagram, right?
No, like, if only chair confirmation is given, then
What determines if it's wedge or dash? Oh, if it's going in the downwards direction, it should be dash. If it's upward, it should be wedge.
very good, very good, very good. That is the most important thing which you need to know. Okay, whenever the bond is on the downward side, then it is dash, and if on upward side, then it will be going wedge. Great. And
Mm-hmm.
then you tell me if I am having a Newman structure.
Oh, Newman structure. There's two different types of Newman structures.
Very good.
You have staggered and anti-staggered or eclipsed, right?
Hmm.
So you're basically looking at the placement of atoms on two carbons, front and back.
Hmm.
So it helps you like look at it from a 3D angle, front and back. So if you want to understand like how it would look on at in a 2D way, then converting into Fisher's the best
Great.
method. So in order to do that, you would need to convert staggered into eclipsed or anti-staggered and then into Fisher.
Great. So after Fisher, we can calculate RNS for Newman.
Mm-hmm.
Okay, very good. Then, do we discuss anything else in R and S except these groups? Do you remember?
Um,
Mm. Okay, what is constitutional isomer?
oh, you're constitutional is like there's no change in configuration or anything, right? It's just like the way that it's connected, the bond atoms. Yeah.
Molecular formula will be same and the connectivity is different.
Mm-hmm.
Then we discuss on the edge. Okay. Okay. So in chair confirmation, how we identify and ensure that the given is enantiomer or diastereomer?
In chair conformation,
Yeah.
can you repeat that question?
Let's suppose I'm having a chair conformation, like I'm having a 1,2-dimethyl cyclohexane and one 2-dimethyl cyclohexane, but the configuration R and S is changed in both of them. Okay, and now I'm telling you that compare both of these structure and tell me that the given both given compounds are diastereomers with each other and enantiomer or what sort of.
Mm-hmm. Yeah.
Hmm. So how you approach those type of questions?
Um, the approach would be You would try to first look to see if there is any sort of symmetry, plane of symmetry, because and then if there is, that would automatically tell you that, there's a mirror image. And if it's a mirror image, then it's an enantiomer. And usually like the distance between, if you look at the mirror image, the distance between each like atom is like in a specific,
Mm-hmm.
it's like consistent. Yeah.
Mm-hmm.
Um, and then the second is if you would have to look at the RNS configuration, which is the best way to determine like, chirality and if the configuration changes. If
Mm-hmm.
all of the configurations change, it's an enantiomer. If only one or more changes, it's a diastereomer.
Mm, yes, all the things is correct, but I want to ask you that I if I need an enantiomer or diastereomers to find out in any confirm in any cyclohexane. So firstly, I need to convert if the cyclohexane is
Pair.
being form, then in chair form. That is the most.
Cyclohexane would be chair conformation, yeah.
Yeah. Sorry. Okay, great. Hmm.
I think like that's the exception because you have different forms like two different types of bonds would be the exception, right? A
Mhm.
cyclohexane, but for the rest, it's a lot easier to see, like wedge dashed.
Yes, yes, yes. And if in stereochemistry, whenever you are having any sort of compounds, okay, any
Mm-hmm.
compound. So how you identify that there is compounds of enantiomer or diastereomer? So
Can you
firstly, you
repeat
are
that?
going with mirror image concept. Then if there is some
Mm-hmm.
issue with mirror image, then you can go with configuration R and
Mm-hmm.
S.
Yeah.
Okay. So I don't think so that you have any issue in stereochemistry. You know all the concepts very well.
Wait,
Seriously, all the concepts you
wait,
know.
mommy. एक टीचर ने बोलते समय शॉप की सुपारी. Yeah. She said that she just asked me a lot of questions like one by one, like if the how would I approach, in this situation. She said I know everything. But I think I need more practice with like,
Yes,
yesterday what you
yes.
were showing me, the cyclohexane. I think that's maybe I needed more practice on
I
that.
think you need not more practice. I think you need a little bit patience whenever you solve some questions. Okay. So I think from today's I will give you only five questions. Okay, so your concentration on that five questions increases more as compared to if you are getting a lot of questions. Okay, I
I
think so.
see, yeah.
Yeah. So that is your problem.
Okay.
If you are getting a lot of questions, you are a little bit confused, and you know.
Yeah,
So I,
I just get very overwhelmed. I was just looking at the document, it was like 9 pages. Like, I don't know how I'm gonna face you. Are you gonna like judge me for not doing all of them? Like, I was like, I don't know what's gonna happen.
no,
So
no,
I was a little scared about that, but
no.
um,
Yes,
I
you are like overburdened when I gave you a lot of questions.
I was
Mm,
really overwhelmed because there's like three different documents and they have so many. I was like, did she expect me to do all of them by the next session, or like, is she gonna get upset or something? I don't know what the expectation.
no, no, no.
Okay.
You needs to do questions, like 4 to 5 questions for a day. That is, I think, so enough. But like from today's, I will share only 5 questions with you, and the 5 questions are on the basis of your daily classes. Okay, so that is, I think, more helpful. Okay,
Yeah.
great, great. Okay, so I think now we need to start our organic reaction mechanism. Can we start?
Yeah.
So firstly, you tell me something. Do you know about nucleophile, electrophile?
Yes.
Great. And do you know about inductive effect, mesomeric effect, and
In
hyperconjugation?
Yeah, hyperconjugation, I know, and then inductive, I know. The other ones, I don't know if it's in our syllabus in America or my college, so I'm not sure.
Aromaticity. Do you know
Sorry, give me
aromaticity?
1 second. Kind of, yeah, I think so. Not really. I don't know, maybe not actually. I might need a refresher on that.
Okay. Okay. If you know nucleophile, electrophile, in electron withdrawing group, the donating group.
Okay.
Then
You can also, I feel like it would be maybe helpful, like, because I did say that send Dhananjay sir again the list of topics, like under reaction mechanism. Oh, I don't think they mention. No, they might mention like under reaction mechanisms, are there certain like topics? I mean,
under reaction mechanism. Give me.
yeah, I don't know if
When
Dhananjay
you
sir can
said
send.
like tomorrow only, or like yesterday only.
Yeah, sorry.
Do you like did you share the topics yesterday or
Oh no, no, like not that long ago, like before a session. So
and that okay? And they share a PDF that is reaction mechanism, stereochemistry, multi-step synthesis of a variety of organic compounds such as aromatic alcohols, phenols. Those topics, na?
yeah, alcohols, phenols, amines, heterocyclics. I would focus on these
Mhm.
probably for reaction mechanisms. I don't think
Yes.
aromaticity. I just wanted to double check. Is aromaticity here? I don't
These
know if it.
aromatic compounds, we need aromaticity.
Oh, okay, okay. Yeah. Okay,
Okay.
then I think I you can just proceed as you are then. Yeah.
Mhm. Okay. So, do you know how many types of organic reactions are there? Hmm?
How many types? There's SN1, SN2, E1, E2, radical reactions.
Mm-hmm. Addition,
I,
elimination.
yeah.
Okay. So you know all the basics, I think so, in reaction mechanism. All sort of basics.
I'm not sure about addition and elimination. I would have to look. No, sorry, not what is it?
Yeah.
Addition?
Addition reaction when let's suppose I'm having a alkene,
Hmm.
okay, and HBr, let's suppose H2O, and all sort of that nucleophile will attach to alkene on the double bond. Okay, let's suppose. Okay, so
Oh,
let's
okay, okay,
start.
okay.
If I'm having this double bond, okay, and I have X and Y molecule. So X and here is Y. This is addition reaction. When
Mhm.
two atoms attached to this double bond. Okay. And what
Mhm.
is elimination when two adjacent element removed from this? So addition reaction and elimination is reverse to each other.
Wait, sorry, let me just write this down.
Mhm.
Just so I don't have issues later. Okay, just write this down. So you have an alkene, right?
Mhm.
Um, and then you add, so you have X, Y, and then it becomes a structure, another structure with X and Y in it. So that's this is like the idea of addition reaction. Oh, wait, so you have X attacking the alkene and then you also have the product attacking alkene. Is that, did I understand correctly? Or
Hmm. See, whenever any sort of compounds will attach to a double bond,
Mhm.
okay, that is addition reaction. We need to add atoms to a particular element, okay, that is addition reaction. And when elements will remove in that case, then it will be elimination reaction.
Oh, I see. Okay.
Okay,
That
that
makes
is,
sense. Yeah.
and after that, see, now I'm giving you some example, and you tell me that the given is nucleophile or electrophile.
Okay.
Because nucleophile and electrophile is little bit important in each reaction.
Mhm.
Okay. Okay. So firstly, you tell me what is nucleophile.
Nucleophile, it loves, what is it? Electron loving, right? Like,
Mhm.
what is it called? Reactants? Not, I don't know, not reactants. What is it called? I don't know. Like
Yes, yes. You can say reactant or
electron loving?
any
Huh?
group, any groups.
Oh, any group, yeah.
So any group
Uh,
which
it like attracts electrons towards itself. So it likes to seek out groups that are very like,
attracts electron, like is
oh,
nucleophile electron loving?
no, sorry, that's electrophile, right?
Yeah.
Okay. Uh, nucleophile. I see. Nucleophile, I think that would mean like it likes to okay, yeah, donate.
Donate
Opposite
electron.
of electrophile.
Yeah. And in electrophile, it accepts electron. Okay.
Okay.
Great. Then, so whenever any group is having a negative charge, okay,
Mm-hmm.
and double bond or triple bond. Okay, so you remove double bond and triple bond. You can say only negative charge species are work as nucleophile majorly. Okay. And if the species is positively charged, then it is working as
If it's positively charged, it's gonna be electrophile, right?
yes. Okay. So let's suppose I'm having a Cl minus, Br minus, I minus, F minus. So they are working as electrophile or nucleophile.
That will be nucleophile.
So can I write here X minus? What is X? X is halides. Okay. So it can be F
Mm-hmm.
minus, Cl minus, Br minus, and I minus. Okay. These are
Mm-hmm.
halides. Then I'm having cyanide. What is cyanide?
Cyanide, it's a toxic compound,
Cn
right? I'm forgetting.
minus. Okay, Cn minus group is cyanide.
Yeah, C minus.
Then OH minus. Okay.
Mm-hmm.
So these are the compounds which is having negative charge. Negatively charged groups are nucleophile. Then with negatively charged, if any group is having lone pair, okay,
Mm-hmm.
any group which is having lone pair, they are also working as nucleophile. Let's suppose ROH. In case of ROH, oxygen is having lone pair. Okay. Let's suppose H2O. In case of H2O, this oxygen is having lone pair. Then NH3. So in case of NH3, nitrogen is having lone pair. Okay.
Okay.
Yeah. And now the term coming electrophile. In case of electrophile, the examples is like H positive, Cl positive, Br positive, I positive. Any group which is having positive charge. Okay.
Mm-hmm.
NO2 positive. Those are electrophiles. So as a nucleophile which is having lone pair, they are also known as nucleophile. So in case of electrophile, if any compound having vacant orbital,
Mm-hmm.
so they are also known as electrophile. What is vacant orbital?
Vacant orbital is like it can accept electrons in that, right?
Yes, yes, very good. BF3 and AlCl3.
Usually they're P, D, and F orbitals, right?
Yes, majorly that
P.
PDN.
Yeah.
Okay. Any doubt in nucleophile and electrophile? Hmm?
Um, no. Wait, so usually Cl is
Mm-hmm.
negative, right? Cl,
Yeah.
Br, I.
Yes,
So then
yes.
it can also be positive depending on like the
Yeah, depending upon
reaction.
reaction and anything.
Oh, okay.
Hydrogen can be positive, hydrogen can be negative also, okay?
Okay. It just depends on the context or like what we're looking
Yeah.
at.
Yes.
Okay.
Okay. So this is electrophile and nucleophile. Okay. Now we will start with the major topic. Okay, like alcohol, alkene, and all of that. Okay.
Mm-hmm.
So for alcohol, we will start firstly. Sorry. And as we discussed that whenever we start any topic,
Yes.
we will start with their IUPAC name.
Okay.
But whenever we start any topic, we will start with their IUPAC. Okay.
Yeah.
Okay. So let's start with. Give me a second. Give me a second. Okay. Let's start with alcohol. Okay. So let's start firstly with the uh, classification part.
Mm-hmm.
Okay. Classification parts. So on the basis of firstly, we will identify like on the basis of OH group. So alcohol means which group, which functional group attached to any particular species. That is
Oh,
OH.
oh,
Okay.
yeah.
So on the basis of the number of OH groups attached, the classification will proceed. Okay. So let's suppose if a atom having one OH group, so that is known as monohydric.
Okay.
Okay. On the basis of OH group. So let's suppose if I'm having one OH group on a particular element. So let's suppose if it is a C2H5OH. So how many OH this carbon having?
How many OHs?
Yeah. How many
So
OH? The first compound.
in the first compound, like how many? There's only one, right? One
Yeah.
group,
Yeah.
alcohol group.
Yes.
Okay.
So the first is known as monohydric. Then second is having two OH groups. That is known as
Two OH
dihydric.
group, yeah,
Yeah. And if three, then
try.
yes. So the first is monohydric. Then the second is dihydric. Then the third is trihydric. Okay. Like
Okay.
on the basis of OH groups, we are identifying that the group is monohydric.
Okay.
Okay. Then on the like this is the first part of classification. Then the
Okay.
second part is depends upon like the carbon which the OH will attach. Do you remember 1 degree, 2 degree, 3 degree?
Mm-hmm.
Okay. So 1 degree is known as primary
Okay.
on the basis of carbon. Okay. So let's suppose this is OH. There's this one, and here is this one. CH2, CH, and C. Okay. So tell me, what is the difference in between them?
The difference is how many substituents there are on the carbon. Outside of hydrogen, oh, the number of hydrogen substituents, right? Or sorry, wait, hold on.
Do you remember the 3 degree, 2 degree, 1 degree concept?
Yeah. Like this,
Mm-hmm.
like, is different from this.
Mm-hmm.
Like the,
So which is
yeah.
3 degree?
Hmm?
Which is 3 degree carbon?
Oh, which one is 3 degree? It's gonna be the first one, right?
Yeah. So this is 3 degree. Three
Mm-hmm.
degree alcohol.
Mm-hmm.
Okay. This is 2 degree alcohol, and this is 1 degree alcohol. Sorry. 1 degree alcohol. Okay. And 3 degree alcohol is also known as tertiary alcohol,
Mm-hmm.
and 2 degree is known as secondary, and 1 degree is known as primary. Okay.
Mm-hmm.
So this is also a classification of alcohol, but this is based upon carbon. Okay. So like
Mm-hmm.
the carbon is 3 degree or 2 degree or 1 degree.
Mm-hmm.
Then any issue in classification part? Hmm?
No.
Do you remember the 3 degree, 2 degree, or 1 degree?
Yes, I do.
Great. Then let's suppose I'm giving you some example, and then you identify that the given uh, alcohol is 2 degree or 1 degree. Okay.
Mm-hmm.
Okay. Tell me the first organic compound is 1 degree, 2 degree, or 3 degree.
The first organic compound, it is just one, right?
Sure.
Primary, yeah, it's primary, right?
Yeah.
Mm-hmm.
And the second one is
Tertiary.
it's tertiary. Okay.
Mm-hmm.
Then if see in this case,
Mm-hmm.
Hello.
Yes? Sorry, what were you telling me to? Sorry, I thought you were still writing something.
I thought that I'm talking and you are not responding, and my mic is on the mute. I forget that.
Oh, no worries.
Okay. So we are discussing that carbon is this part. In this part, carbon is sp3 hybridized. Okay.
Mm-hmm.
So what if is the carbon is sp2 hybridized?
If it's sp2 hybridized.
Hmm. Tell me, is the carbon is
Mm-hmm.
sp2 hybridized or not?
Which one? The first one? Which one?
Yeah, all the carbons. Let's start with this one.
Mm, not the first. That carbon. One, two. Yeah, SP or SP2?
sp or sp2, like what is sp3, what is sp2, how we identify that the carbon is sp3?
Which carbon? The first one?
This
Okay.
one.
I think it's SP.
Hmm?
I think it's SP.
Okay, so any carbon which is attached with single bond, so
Mm-hmm.
that is sp3. Okay, any carbon which attached with double bond, that is sp2. Any carbon which is attached with triple bond, that is sp. Okay, so these things you can note down. So now you tell me that the given carbon is sp3 or sp2.
It would be SP3.
How? Don't
Or
you think that the carbon is attached with a double bond?
mm,
Where are you? Like this carbon is attached with double bond, na?
yeah, there's two hydrogens and then a double bond. Okay, yeah, SP2.
Yeah. And this carbon, this one.
SP2, right?
Yeah. So, uh, whenever OH is attached, whenever aliphatic OH, okay, aliphatic, aliphatic alkene there, and if OH or OH attached to direct sp2 carbon, then this is known as vinylic alcohol. This is important term which you needs to know. Okay, vinylic alcohol. Whenever OH attached to a carbon which is sp2 hybridized, okay, and that is aliphatic in nature. What is meaning of aliphatic?
Not aromatic.
Not aromatic or a single chain.
Hmm.
Okay, a chain like structure. Great. So that is vinylic alcohol. Great. Then this is the classification of alcohol. I almost write all the things which you need in the classification of alcohol. Okay. Now we will start with
Wait,
uh
sorry. Can you give me 1 second? I forgot to copy. Hold on. Just give me 1 second.
you
Okay.
can after the class, after the class in the end, because there is a lot.
No,
Or
actually, it's more inconvenient because when I take a picture on my phone, I can't even like see it
yeah,
properly because
yeah,
it's
yeah,
small, and then I
yeah.
have to move it, and I have to go back watch the video. I think it's just like wasting my time, so I'd
Yeah.
rather just copy it
Yes.
down.
Great. You can.
Yeah. But here the reason I got confused is because so this carbon, like I thought it was attached to this hydrogen, like these two, but then because it's these two, there should be these other two bonds on this end. So I misread the structure, like how it's attached, if that makes sense, from this formula
Hmm.
bond line.
Yeah, we
Like,
can
like,
reset
does that make
it.
sense? Like,
Like,
yeah.
okay, we can reset this.
Oh, okay. Right, right. Okay, I see it now.
Hmm. Okay, so can we like move further?
Mm-hmm. Yeah.
Can we, or you want to write down?
No, 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 I got it down.
Okay. Okay, now let's start with IUPAC nomenclature of alcohols. Mhm. So what is the rules of IUPAC naming? You are writing down with me only, na?
Mm-hmm.
Do you making notes with the class?
I'm making notes like whatever you're writing down.
Great, great. Okay. So, what is IUPAC naming and why we need?
It's
Okay.
a nomenclature. It's a system of
Yes.
naming compounds and classifying them.
Why we
So
need IUPAC? Doesn't we have any common namings or anything like that?
because it's very specific and like it tells you kind of like what functional groups are where and like how many of them and how they're arranged
Yes, yes,
in a
acidity.
molecule. Yeah.
Mhm. Yes, that's
Whether
why
it's like
IUPAC.
double, single,
Mhm.
triple bond, things like that.
Mhm. Yes, IUPAC naming is used because it tell us the name of compound in very detail. The first thing, okay.
Mhm.
Then the second thing that if we are using common name means like common name is mostly used for the scientists which are discovering a particular organic compound. Okay, so let's suppose if I am in India and I discover a organic compound, let's suppose anything, and I gave that particular compound on the basis of my name. Let's suppose I gave compound name Shruti. Okay, so and if you discover that particular compound and you gave that particular compound on the basis of your name. Okay, so in the books, in the references, there is two compounds which is having same identity, same proof, but they are showing different. Why? Because of the lack of communication of two scientists and the lack of a nomenclature portion. Okay, so that's why in the end a particular nomenclature or naming will start for compounds, so the compound will not copying by each other and having a fixed standard or reference data. Okay, that's why we are using IUPAC name.
Mhm.
then then how we identify IUPAC nomenclature? Firstly, what we are going to do, firstly we check a long carbon chain, longest carbon chain. Okay, longest carbon chain. First, we are going to discover longest carbon chain. Then, second, the functional groups. Wherever functional group is present, we are giving that particular carbon. Functional group starts from any carbon, so we are giving that carbon first priority. Okay, you need to note down this thing that is very important. That from where like the carbon chain can be start from left hand side and right hand side. So the functional group comes at any side nearby. Let's suppose I'm having this carbon, and here is OH. This is the first thing, and here is okay. So now I need to give numbers to each carbon chain. So how I will start? Let's suppose there is two possibility: first, second, third, and fourth. Okay, and there is another
Mhm.
possibility: first, second, third, and fourth. So how, like, which possibility, which priority order is correct? This one, because functional group attached to this carbon. Okay, so wherever functional group comes first, we start with that carbon. Okay, let's suppose here is two possibility: first, second, third, fourth, fifth, and sixth. Okay, and another is first, second, third, fourth, fifth, and sixth. So which is correct? Tell me.
It should be the shortest chain, right?
Shortest chain.
Or like, so the longest chain defines the basis of the molecule.
Mm-hmm.
But if you're looking at the functional group, I think you would look from like where it's like shorthand from like whatever side. Like in this case, it
Mm-hmm.
would be, yeah, from
Which
the
one?
right or yeah.
Great. So we need functional group least, at least prior, at least means, you can say first priority. Not we can write here priority only. Okay, we are getting more priority. Mm. Okay, then this these two things you need to know in this case only. Okay, and wherever the groups are attached, we are going to name them as the groups attached. Okay, and you can note down that if there is two digits come together, then it will be a comma in between them. And if there is one digit and one, let's suppose alkyl is written, so you need to represent dash in between them. Okay, these are the general uh, rules for IUPAC. Okay, now I'm giving you an example and you tell me what is the IUPAC name for that. Okay,
Mm-hmm.
CH3, CH, CH3, OH, and there's one this one. Okay, so you try uh, these two examples. Okay,
Yeah. Do you want me to like give the name or try to give the name? Mm, Wait, what's this? Ma'am?
yes, tell me.
Sorry, what was this like this group that I circled?
That is not any group. This is
Or
this is like let's suppose I having one. alkyl, propanol. This is the IUPAC name of any compound. So I'm writing here that whenever any digit and any name comes together, so in between them we need to represent a dash. Okay, this dash. And whenever two digits come, then we represent comma.
Mm-hmm.
Okay, let's start with these two questions. Yeah. So firstly, what we are going to do, we just uh, check that OH groups. OH group is there. So firstly, we will identify our longest carbon chain. Is this correct? There is only one carbon chain, so we doesn't need to identify one. Okay.
Mm-hmm.
Then here is first, second, and third. Okay.
Mm-hmm.
So OH at which position? Two.
Yeah.
Yeah. So math at prop. So propane to ol. Okay. Any doubt?
Do you have to take the E out of propane?
Sorry. E out. Okay. No, no. We doesn't need E.
Oh, like propanol. Okay, I see what you mean. Yeah. We just keep it like without the
Mhm.
E. That's all, right?
Now you tell me for this one. How you start for this question?
This one, right?
Yeah.
Um, name the longest chain.
Yeah.
In this case, it's like the
Let's suppose first and second. Okay. So how many carbon? Two. Net at. At. Okay. Then how we identify is ethane. This is ethane. Okay. And first and second both carbon containing alcohol. So ethane one, two, and how many OL oxygen here? So here is di. So it will be di. Okay.
mm-hmm.
Then let's suppose I'm giving you one more that is similar to this one. Mm,
Wait, why do you have to keep the E at the end here
oh, sorry.
of ethane? Ethane.
No, no, we are taking E here because there is two OL here, like the two OH. Okay, when only one OH or one group, one functional group attached, we remove the last alphabet. Okay, and if we are having more than
Oh,
one OH, so in that case we are taking E. Okay, let's suppose for this question, tell me how we will do this one.
um, which one? Oh, um, it's a propane, right? So there it would be 1, 2, 3 triol, right? Pro propane 1, 2, 3 triol, right?
Now tell me for this one.
Um, it would be one. So what is it? It would be
So firstly, we
the
need
longest chain.
yeah, longest chain.
So this, I think this would be right.
Yes, great. So how we will give a UPC name?
IUPAC name. So it would be two, or this is the longest chain, right? So this would be like one, two. Oh my God, I can't write properly. Okay,
Okay, one,
one,
two,
two.
and three.
Oh, okay.
Yeah. Then
Why can it not go in the opposite direction? Or
yeah, you can go with any direction.
okay, so you have like this group that's an alkyl group,
Hmm.
standing out of the
Methyl.
longest chain, and then this one
Methyl.
here,
This
alcohol,
is methyl.
methyl salt.
So math at prop
Mm-hmm.
2 methyl propanol is correct. Is this IUPAC is correct?
Yeah.
Sure.
Wait. Now you're making me question myself again.
We needs to add
I might
two.
be wrong.
Yeah.
Okay.
Why we need two all? Because if we represent 2 methyl propanol only, so in that case, how we identify that OH group at which position? Okay, so that's why we also need to represent the position of OH group also. Okay, so that's why we are adding two all.
Hmm.
Okay.
Yeah, yeah, yeah. I forgot that
Okay.
part. Wait, what's the difference between alkyl group? Alkyl means something totally different. I don't know if I've been using it this whole time without even knowing what it really is.
Alkyl means alkyl is generally used for any sort of like methyl, ethyl, propyl. So in general, whenever we are using any
Okay.
alkane group, which is remove a hydrogen from it, then that is alkyl group. Okay, so methyl, ethyl, propyl, butyl. In general, we tell all these groups as alkyl group. Do you understand?
Yeah, like if it's branching out of something, right? Chain or something.
Yeah, any alkane. Let's suppose I'm having C2H6. So whenever one hydrogen will remove from that, so it will converting into alkyl group. But if we specify which sort of alkyl it is, so two carbons, so it will be ethyl group. Understood? Ethyl. And let's suppose if there is CH4, when one hydrogen will remove, so it will be methyl group. But methyl group is also known as alkyl group because alkyl group is a general way to represent any alkane. Okay,
Hmm.
with like one hydrogen less in there. Okay, so this is IUPAC name of alcohol. Now, today I will give you some questions from IUPAC and classification. Okay,
Mm-hmm.
and then okay, so there is one more thing that is structure. Structure we also discussed. Then we start with a method of preparation. Okay, this is IUPAC naming, and before this class tomorrow, like before the class tomorrow, you share your notes PDF of this chapter to me. Okay?
I'm sorry. My notes, like right now that I'm making.
Yes.
Oh,
Or anytime, like or anytime
okay.
you will make. Okay.
Mhm. Okay. That's interesting. I think you're the first tutor that's like asked me to send them my notes.
So like you will be more
Yeah,
dedicated.
prepare.
More attentive. in the class. Okay, so structure of functional group, like how and what sort of bonds alcohol
Mhm.
having. Okay, so this is the OH. As I told you that how many bonds carbon have, first you tell me. Four.
Four.
So this is four bond. Okay. Then oxygen. How many lone pair oxygen having?
Two, right?
Two, absolutely. Two lone pair. Then just because of two lone pair, this bond of the like the bond, this bond is tilted. Okay, like due to lone pair, they repel each other. Okay, so now you need to know the bond angle in between these two bonds. Okay, so you can wrote
Mhm.
down that 108.9 degree this bond. Okay, and then one more thing, the bond length. This bond length is of 96 pm. Pm means picometer, and
A 96.
this is 142 picometer. Okay, now you tell me how many sigma bonds this group have and what is IUPAC name for this one. And what is
Can you repeat that
hybridization
again?
of
Sorry, can you repeat that?
what like how many number of sigma bonds in this compound?
Um, five sigma bonds and two lone pairs.
Five sigma bonds, two lone pairs. Great. And what is IUPAC name for this compound?
IUPSC name. It would be so there's an alkyl group, right?
Yeah, methyl.
Yeah,
Yes. So,
methyl group. So it'd be like okay, if you look at the longest chain, I guess it'd be this would be one, right?
hmm.
Two.
No, we doesn't need to give a number to
Mm.
oxygen.
Oh, is this only with carbon that you're considering? Okay, my bad. Sorry, I misunderstood. I thought I was like with any like atom, any element. So that would just be one. Oh, okay. So you have what's it called? This group. Is that an ether? Oh, no, no, no.
It's
Oh, it's
alcohol.
not.
We are discussing
Oh,
alcohol.
alcohol. Sorry. Oh, OH. Sorry. Okay, okay. So I'm looking at this separately.
No, no.
Oh, no, no. It can't be an. No, you need two alkyl groups for ether. Sorry. So then this is alcohol, right? This whole thing is alcohol. So it'd be hmm. Oh, methanol. Okay, methanol.
Okay. Now you tell me what is hybridization? Hybridization. Hybridization of carbon here.
Hybridization of only the carbon.
Mm-hmm.
There's one, two, three, four single bonds. So that would be sp3. Yeah.
And what is hybridization of oxygen here?
Hybridization of oxygen. Wait, one, two, three, four. sp3 as well, right?
Great. So this is the structure of functional group. So as whenever we are having sp3 hybridization, what is the bond
Mm-hmm.
angle in a particular sp3 hybridization?
What's the bond angle?
Like
Oh, I don't
standard
know.
bond angle, standard, that is
104.
109 degree 28 second. Okay, this is the standard data. But as we see
Oh.
that in
Oh
this
yeah, and 109. 109.5, right? Something
yeah,
like that.
109 degree 28 second this is standard data. Okay, standard.
Okay.
But in this case we are having 108.9 degree. Sorry, 10. Yeah, 108.9. Yes. This is the angle we are getting in this. What is the reason behind this? Hmm.
The reason behind this is because of collide what is it called? What's the word?
Repulsion?
Repulsion. Yeah. Or no, I was thinking of the alkyl groups. Never mind. Like that's something else. Inductive
No,
effect?
it's because see, which is like which bond angle will decreases this bond angle, and what is the reason behind this? Because of these two lone pairs. Okay, these two lone
Okay.
pairs will repel each other, so these bonds shifts toward this side. Okay, that's why the bond angle will decrease. Do you understand?
No, can you say that again?
Let's suppose I'm having any compound which is having a two lone
Mm-hmm.
pair here. Okay, these
Mm-hmm.
two lone pairs. And this is a bond angle. Let's suppose this is 90 degree. Okay, and
Mm-hmm.
here is two lone pair. So what lone pair will do? Lone pair used to do repulsion, more and more repulsion. So whenever they repel each other, they will shift towards A and B. Yes or no? And then
Mm-hmm.
when they shift towards A and B, the bond in between A and B will decreases by 90 degree. Let's suppose it converting into 85 degree or 80 degree. Yes or no?
Mm-hmm. Mm-hmm.
Do you understand? So that is the same reason the oxygen is having lone pair and it decrease the bond angle by like from 109 to 108. Okay, 1 degree change will be due to lone pair of oxygen.
Oh. So
Okay.
instead of 90 it becomes 85?
Yeah. 109 instead of 109 we are getting 108.
What about because you wrote 90 here?
Yeah. This is for example.
Oh.
This is for example.
Oh, I see. Okay. So, sorry, I just want to clarify. So for like the
Major.
longest chain,
Hmm.
oh, sorry.
Yeah.
Oh, the longest chain, you only look at carbon when you're considering it. Oh, that makes sense. It's just it's a carbon. That only makes sense that it's a carbon chain, nothing else, right? And then everything else is just added like this alcohol or whatever to this the
Hmm.
carbons. That's how we identify it, right? Okay.
Okay. So
And
any
then
doubt? Yeah.
because this is just one carbon, it's methyl, so we're not
Mhm.
considering like the three hydrogen or the three
Hydrogen.
hydrogen bonds.
No. We only
Oh,
count
okay.
the carbon. Okay.
So when you talk about alkyl group, like then like can you show me like just quickly like what I just
What
want
is
to make sure that I have the right idea. Like alkyl group versus methane versus butane, like like
okay,
what's
okay. So
yeah.
firstly, at first, second, third, and fourth. One carbon means meth, eth, prop. You know
Mm-hmm.
these things, na? But okay. Then, if there is a alkane present, so how I will write here? Methane,
Mm-hmm.
ethane, okay, propane,
Mm-hmm.
and butane. Okay.
Yeah.
So, what is the structure of methane? What is the formula of methane? CH4. Ethane is having
Yeah.
C2H6, and this is having C3H8, and this is having C4H10. Okay, this is the formula of
Mm-hmm.
alkane. Then what is alkyl? Alkyl group is same as alkane, but in this case we remove one hydrogen. So here is CS3 and C2H5, and this is C3H7, and this is C4H9. Okay, all these groups are alkyl group, and whenever we remove one hydrogen from alkane, we name this as methyl. Okay, this is ethyl, propyl, butyl, like this. Do you understand now?
Okay. Oh, wait. Sorry. Let me just note that down really quickly.
Hmm.
C2H5? What
Where?
does that say?
Yeah,
Yeah.
C2H5. When we remove
Okay.
one hydrogen from C2H6.
Oh, this is like when you remove the hydrogen. Okay. That makes more sense. So when you're naming these IUPAC, you're only looking at like you're not looking at the alkyl group or
No, we are looking for both. Let's suppose if I am having organic compound. This is the organic compound. Oh, it's over here. Okay. And one CSC over here. So now how we will start nomenclature for this. Firstly, we start to give numbers. So from where side,
Mhm.
from which side I will start? From OH or from the left hand side or from right hand side?
Left.
Left. We need to start from where the functional group is attached only, na? So
Oh,
first,
sorry.
second, third, fourth, fifth. So five carbon. Five carbon means pent,
Yeah.
pent, ठीक है? Pentane, two,
Pentanol.
yeah. At which carbon all? At first
One.
carbon all.
Oh, one.
Okay.
Okay.
And there is CH3 left at third position. So how I'll write? 3 methyl, okay? Pentane, 1 all. Do you understand?
Yeah.
Okay. That's why we are using alkyl group.
Okay.
Yeah. So do you want to take a screenshot of any?
No, I wrote down all the notes because
All
I
the
don't want to risk because I've like lost some of the notes,
yes, 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 yes. Good.
so
Great.
it just takes like so much time to do them like
Mm-hmm.
again. So yeah, just
That is
write them
very
down
time
the first time.
consuming.
Huh?
That is very time consuming. And you're like,
It's
I don't
very time consuming, so no wonder why I was like struggling to do the home. I think I wasn't prioritizing the homework. I was prioritizing like the notes or something. I don't know.
mm-hmm.
I think I should have just prioritized doing the problems because I think I like understand the notes for the most part. It's just like,
Mm-hmm.
the lectures and stuff, like the concepts I do get them. It's like I just need to see them in various different contexts, right? And like problems. That's the main.
Yes.
So I can understand like in what context does a concept show up. Like it's not just about knowing it, if that makes sense. Like the approach
Yes,
too, I
yes.
think is
Approach
important.
to
Yeah.
yeah, approach to a particular question. Yes, that's the major important thing in organic chemistry, especially because if we study
Mhm.
inorganic and physical, by the notes
Mhm.
we can easily solve the questions. But in case of organic, we need to practice a lot of questions. Then we understood the application part of the theoretical portion. Okay, so in organic we need, and today I will share some questions from alcohol. Okay,
Okay.
any doubt from alcohol part up to now?
No, I don't think so.
Okay, great. Then we will meet in next class. Okay.
Okay, so should I just disregard the previous handouts that you gave me?
Yes,
Documents?
yes, yes. I will share today for
Okay, okay.
you and for this part. Do you need for this part? No, na? Or you
Just in
want?
case I would want to practice it because I'm not 100% sure, confident.
Okay, okay, okay. I
Yeah,
will share. Okay.
on IUPAC. Yeah.
IUPAC and classification both I will share.
Mm-hmm.
Okay then.
Okay. So is the expectation like I should be doing these before like tomorrow, I guess? So I
I'll
can be more
share
prepared.
two or three questions only. Okay, today. So
Okay.
I think you
Okay.
do all that questions if the questions is lower in number.
Yeah, it's like more bite size. I think that's a lot better for me, although
Yeah,
like
yeah.
yeah.
Hmm.
Okay then. I'll just focus on
Okay.
those questions and yeah, thank you so much.
Okay, great.
All right.
Bye.
Thank you. Bye bye.